Hello everyone, welcome to the session. In our today's session, we will start with the index. So what is index? See, index is very important for performance tuning. So whenever you are going for any interviews related to Informatica or related to IACS or related to SQL projects, so definitely the indexes they will ask more questions. So what is indexes? So index is nothing but by using index, you can retrieve the data. Okay, so fast retrieval by effectively managing the data. Okay, you can retrieve the data from the database very fastly. So that's what the indexes helps. So what is index? So index is a different object. What is a different object? See, we do have different objects, right? So here we have the tables. Here we have the views. Here we have the views. On top of the tables, we will create a views, right? So this is views. So table is one kind of object. Views is another kind of object. And indexes is another kind of objects. So index also different objects. For an example, if you take this is an index. So whatever the tables in real-time projects, so we are going to store the data in the database. It is not as like 1,000 records or 10,000 records. So we do have huge volume of data. It's like a millions and billions we will have the data, right? So since we are having a huge volume of data and retrieval, okay, say for an example, in the real-time project, any databases don't select this way. Okay, don't select this way. So any tables don't select in this way. So why? Because if you are selecting this way, right, it may hang. Okay, so why? Because if the table has huge volume of data, if you are using select star from the table name without where class, if I have the billions of record from this table in particular table, your system will get hanged. To avoid this, normally what we have to do, we have to check whether this table has been partitioned. So always you have to check whether the table has been partitioned. So you may have the partition table, right? So instead of having all the data in a single partitions, we will be having a different partitions based on some values. This one we will see in our next session. Performance tuning session, we will see that what is partitioning, how to create a partitioning on the tables. But if you are seeing the partitions, select star from the table name where, so you'll be having a partition here. For an example, it's a transaction date. So you have the transactional date, you are using partitions or country equal to India, you are partitioning. Okay, country wise, you are segregating the data. So mostly, most of the transaction tables, all these tables are partitioned with the date column. So that particular date column you have to use created at, okay, created at, created by, created date. So all this you'll be using here. So that is what you will go for the partition by. The same way, if you have a data, if you have huge volume of data in the database, if you are selecting select star from the table, you are using some where clause. So you are using any select statement. Select star from a table name, transactions. Okay, where you are using some column here. Okay, where transaction status, something like that equal to success. Something you are checking in what Oracle will do or database will do. If you do not have any indexes on the table, it will go and check every record. Okay, whether status equal to success? No. Status equal to success? No, no. Yes. So it will check one by one all the records. So that is called full table scan. So what is that? Full table scan. So each and every record it will go and check, and then it will find, okay, these records are transaction status equal to success. That's what it will find. So this is the meaning of full table scan. If any tables is going for full table scan, definitely it is a performance issue. So why? Because if you have huge volume of data, so our database is going to check each and every record one by one. It will take a lot of time. Sometimes it will get hanged also. So to avoid this kind of scenario, we need to go for some performance tuning method. So what is that performance tuning method? So indexing is one of the performance tuning method. So what is index? Say for an example, you have a book. You have a book. The book has 1,000 pages. You assume that the book has 1,000 pages. Okay, it has 1,000 pages in the book. It doesn't have any content page or index page. So I'm asking you one particular topic. I'm asking you to take that some details on the topic. The topic is available in the book. So what will you do normally? In the book, I'm taking one particular topic. The topic is there in the particular book. I'm asking what is the details about the topic. So what will you do normally? If the book doesn't have any indexes or content page, one by one you'll be checking all the pages, right? One by one you are checking all the pages, and whatever you are checking the title or details, it is there at 950th page. Okay, you assume that. So that means unnecessarily you are searching all the 949 pages and you are finding it, and remaining pages also it will go and check. So why? Because so it may contains other pages also, right? So instead of checking all the pages, if you have content page in the front, okay, if you have the content page here, that means index page on the first page. If I'm asking you to take one particular topic, so first where will you search? First you will go to content page. You will take the page number, right? Page number 50 or something, or some 950 or something. So you will take the page number from here. Then you will go to corresponding page number. You will take the details. See, this time, if you have the content page, then it is very easy to check the data, right? So if you do not have content page, how much time it will take? If you have the content page, how much time it will take? So here, this is the performance improvement. Same way, if you have indexes, if the table has many data, if you are creating the index on the table, so what Oracle will do? So whatever the data has been stored here, so that details will be stored here on the index table. Okay, this is an index table. So index, this is a separate object. It is a separate object. So wherever the data has been stored, all that information will be captured on the index table. Then it will put an entry. Okay, so it knows, this particular table knows it where the data has been stored. So you are selecting some data from here. Select star from the table name where some column you are using. So that particular, if you are searching it, so first Oracle will go to the index table. If the index is available, it will go to the index page. So in that index page, it will take the row ID of the record. Okay, row ID it will take. So row ID of the record. Then with this row ID, it will go and search here. It knows where the row ID is present and it will give you the data. So index is a separate object. Okay, so index is the separate object in the database we do have, and it will take the data. So clear what is index? So index is the separate object. Okay, so how you will create an index? That's an important, right? So we do have a different kind of index based on the data. So we do have different types of data, so uniqueness, repeat data, all this. So based on the data, we need to create an index. So how to create an index? So that's what we are going to see. So index is a schema object. So I told, so index is a schema object that contains an entry for each value that appears in the indexed column. So you have indexed column. See, if you have hundreds of columns, no need to create index on all the columns. Whatever the column, you are going to frequently query that column. Okay, whatever the column, you are going to frequently query that. So that particular column should be indexed. So that's what indexed column of a table or a cluster. Okay, cluster is nothing but so one kind of like a partition and provides a direct fast access to rows. Indexes are used to search the rows in the Oracle table quickly. So in index, we do have cardinality. So based on the cardinality, you have to create an index. So what is that? So we have two types of index. One is unique. So different types of indexes are there. I will tell you what is that. So unique and non-unique index. If you are creating any primary key, okay, primary key on the particular column on the table, so index automatically will be created on the column. Okay. For an example, customer table, customer ID, you are creating an index, sorry, primary key. So that means this particular column will get indexed, the index table. What is the index it will create? Since you are creating a primary index, it will create an index called a unique index. So it will automatically create. You are no need to create by yourself. So automatically create unique index. Non-unique index means we are creating the non-unique index. So that is our, if you are not creating a primary key column, that is a non-unique index. Oracle creates unique index for primary key and unique key constraints. If you are creating unique key constraints, primary key constraints, Oracle will automatically create a unique unique index. If non-unique indexes are already present on the column, okay, say for an example, one column has been indexed already with non-unique index, it will not create new unique index for primary key in Oracle. Okay, remember this. If index is already exist, the table, after creating the table, so you have indexed it, some particular column, for an example, mobile number, or some column you have indexed it, but after that you are creating that column as a primary key. Whether it will create a unique index? No, it will not create unique index. So we do have composite index, composite key, you know, right? The same way, if you are creating an index by combining more than one column, so that is called a composite index. Function-based indexes. Function-based indexes means the indexes column. So you are creating, okay, for an example, you are using upper of first name. So first name column, you are going to create an index. So this first upper of first name is the function based index. Why? Because you are passing the function here, right? Upper, lower, all this. The indexed column data is based on a calculation. So that's a index function based indexes. Okay, first of all, how to create an index on the table? Okay, select star from employees table. So how do I know whether this particular table has been indexed or not? The same way you have to select star from all underscore indexes. So this is one of the metadata table, dictionary table we do have, and this in this table it will make an entry. So you have to use where owner equal to HR and table name equal to employees. So you are using the table name, right? And table underscore name equal to whatever the table you are searching for. You're using employees. This is case sensitive, that's why you have to use. Table name is employees. Okay. So in this table, 6 columns has been indexed. So what are the 6 columns? You have the email and employee ID, department ID, job ID, manager ID, and employee name. Okay. So we do have one more table. So to find which column it is indexed. So in that table only you can find, okay, which column. So why? Because here we do not have a indexed column, right? So which column it is. So join index, all the details you can see here, visibility. So all this we do have. So valid or not. So when it has been indexed, so all this unique. Okay, so if you are creating employee ID, yes, it is the employee ID is the primary key, right? Yeah, unique index has been created. Email ID is the unique constraint we have created. That's why unique index has been created. All other indexes are non-unique indexes. Okay. For an example, if you are going to create, if you are going to run, so always you are going to run this particular statement. Select star from table name. You are going to select where salary, some salary you are going to check. If the column is not indexed, that means it will go and check every records. Okay, if you are going to check this way, each and every record it will go and check, right? So then it will get you the data. But if the particular column has been indexed, then it is very easy to check. So how to create an index? It's very simple. Create index name IDS underscore salary. Okay. IDX EMP underscore salary on table name on employees table bracket you have to mention salary column. So if you are using this way, this salary column has been indexed. This salary column has been indexed. You can see here. Now, if I'm going to check this, so one more index will be available, 7, right? Salary index, this column, non-unique index. So all this, right? You are seeing that. So how the index has been created, all this you are able to see. But the thing is, so I want to know which is the column, right? So which column it is? You have to go and check the dictionary table. I have already given, right? Dictionary table. So which has the, so indexes. So index column. This is another table. So you have to take this one, select star from this table indexes. So this is the way you will have, and here also you can put owner equal to, okay, index owner and the table owner. See, index owner, table owner. So index is one schema, table is another schema. If you have, then this is what index owner and table owner you have. So mostly you both will have on the same schema, and you can see this joining of the index name. Okay, so get the joining of index name, then you will get the column name, which column has been indexed. So this column has been indexed with first name, last name, manager ID, job ID, department ID, employee ID, all the column has been indexed. So that's what we can find the indexed column. Yes. So if you put the explain plan, if you have a huge volume of table, then you can find the cost for this particular query. Before index, after index, the cost should have decreased. So that's what you can go for the indexes. So what is the index? This index is called non-unique index and normal index. Okay, clear? Non-unique index, simple index. Simply you can create an index. You can go for composite index also. By combining two columns you can create. So whenever you are using the where clause by combining the columns, then it is very easy to pull the data. So this is what the index will be takes place. Okay, so in order to create an index, we have to consider few techniques. Okay, say for an example, if I'm going to create an index on this table, so if you are creating index on the already employee ID has been created. Okay, email ID you are going to create. So email ID will have a unique values for all the records, right? And what about job ID? Job ID is not a unique record. So it will have same jobs for multiple employees are there. Yes, IT programmer. Yes. If you are creating index, so for all this record, it will maintain value. So it is different way it will store the data, how the index table will maintain, right? So even if you are creating indexing on the department ID, it will store the data in different way. So based on the data, we have to create an index. So mainly we have two indexes. So one is BTree Index. So this is the default index. Okay. So by default, if you are creating any indexes, say for an example, this indexes I have created, right? So by default, it will go and create index on the BTree Index. If you don't mention anything here, it will create BTree Index. And we do have bitmap index. So what is that? So we have to define whether it is a BTree or bitmap. And other indexes I will tell you, but these two are a main index in the Oracle database. So if you don't mention index types, so automatically it will take BTree Index. Clear? So what is that BTree Index? Normal index is by default Oracle creates BTree indexes, bitmap index, which store row IDs, okay, associated with the key value as a bitmap. I will tell you what is that bitmap. And partitioned index. So if you are creating a partitions on the column, it will create partition index, function-based index, domain indexes. But out of all this, we'll go for BTree and bitmap indexes. In order to create the indexes, we need to have some prerequisite in the database. So normally in real-time project, DBS will take care of all this, but we do have some prerequisite. What is that? To create an index in your own schema, one of the following condition must be true. The table or cluster to be indexed must be in your own schema. Yes, on the same schema, you should have the table or cluster. You must cluster means it's like a partition. I will tell you partition next week. You must have the index object privilege on the. You should have the index object privilege to create index, and create any index system privilege you should have, and to create an index in another schema. So you are referring one schema table with another schema, then you must have create any index privileges. Okay. But this one, if you do not have for your schema, you have to contact your admin and then you have to ask them, okay, I need this kind of. So first of all, BTree index is nothing but it's a balanced index. So what is a balanced index? What is a balanced index? If you have a unique value, if you are going to create index on unique value column. Okay, so first of all, you will have a cardinality. So cardinality, what is that cardinality? You have to check. Okay, in Oracle, so we have the cardinality. So based on the cardinality, we have to go for indexes. So what is the cardinality? Number of distinct record. So this is what you have to calculate. Number of distinct record divided by total number of record. This is the cardinality to find. For an example, I want to find cardinality on employee ID column or email ID column. So what is the cardinality? If you have 100 records, you assume that. Okay, all the 100 records are unique records, right? So what is the cardinality on employee ID and email ID? Cardinality equal to 1, right? So this is called high cardinality. This is called high cardinality. So maximum cardinality number is 1. So if you have high cardinality, then you have to go for BTree index. I will tell you why we have to go for BTree index. If you have less cardinality, say for an example, you have job ID or department ID or country, whatever it may be. Okay, repeated values, more repeated values. Job ID, 10 unique job IDs are there, or 10 unique department IDs are there. So what could be the cardinality for this? You'll be having 10 divided by 100. So you'll be having 0.1, right? So it's nothing but it's a very less cardinality. It's a very less cardinality if you have, then you have to go for bitmap index. So why? I will tell you. Okay, bitmap index. Why it is? What is BTree index? How the index is stored in the data? How it will be stored in the index table? If you take even 1 million record also, you have 100 records here. You assume that 100 records there on the employee ID column. Yes, it will take all the 100 record. First of all, Oracle will split this 100 record into 2 different group. So employee ID 1 to 50, one group. Okay, employee ID 1 to 50, 51 to 100, it will go to the another group. This is another tree, the tree. Then you have this one again splitted into 2. Okay, this is the another splitted into 2. 1 to 25 employee ID. Okay, 26 to 50 is another one, another node. The same way here also it will go for 51 to 75, 76 to 100. So this is the way it will go for. Again it will go for 2. It will go up to leaf nodes. So the final node we will call it as leaf node. So this way it will go for the leaf nodes. It will split up. If you are searching any values based on employee ID, if you are searching any value, select star from employees where employee underscore ID equal to 170. If you are searching, this is the one of the query you are going to run. You assume that 170. So how Oracle will take So first oracle will go to the indexes table. First oracle will go to the indexes table. If you are running this column has been indexed already, right? Employee ID. So it will go to the index table. So 170. So it knows, it will start from here. It knows where the 170 will be. Yes, 170 will be. That means starting, okay, you assume that 70. Starting from 100 employee ID, it's 70, you assume that, okay? It knows that 70, where is the 70 is available. It will go to second of, right? Then it will go to this one. Then it will go to 70 is nothing but, so here it is available. So this way it will choose the path. That means Oracle will not go and search these records. Oracle will not go and search these records. That means 50 records, it will not go and search here. Here 25 records, it will not go and search. It will find the path where the record is stored. This row ID will be taken and then it will be given to the main table. Only it will go to the particular row ID, it will give you the data. So that is what it will go for the BTree Index, balanced tree index. So if you see this is one of the explanation I have given, but this is the internal structure of the BTree Index, how it will be. So this is branch, blocks, leaf blocks. So leaf is the last one. So if you have a value 0 to 250, so it is taking three different branches now. So 0 to 40, 41 to 80, and so on, and 200 to 250. So that means it is taking some 50 records, 40 records, all this splitting. So again, it is splitting this 0 to 10. Yes. And then 11 to 19, 20 to 25. Like this, it will split up all the records. So 0 row ID, 1 row ID, 10 row ID. It will be stored here. Row ID will be stored. If you are searching any values, so where it will be stored, for an example, this will select this particular path. It will choose this row ID and it will give you this row ID, so that it will not go and search other leaves, other nodes. So that's what the BTree index will be performed and it will give you the data very quickly. But this one you need to go for, you have the unique values, more unique values, you have to go for BTree indexes, more unique values. BTree index store the row ID and the index key value in the tree structure. So if you go through it, then you can find here, and this is what the BTree index. Okay. So advantage, all leaf blocks of the tree are the same depth. Yes. BTree index automatically stay balanced. Yes, we have the balanced one. All blocks of the BTree are 3/4 full on the average. Like it will take the values, it will go for splitted into divided by 2. It will go on to the leaf nodes. But finally, balanced tree provide excellent retrieval performance for a wide range of queries, including exact match and range of searches. So even you can go for employee ID from 170 to 180. That is also you can go for. Insert, update, and deletes are efficient, maintaining key so key order for faster retrieval. Performance is good for both small and large tables, does not degrade as the size of the table grows. Yes, this is the one advantage of BTree indexes I have given here. So what is BTree index? It's a standard index type. By default, it will create a BTree index only. They are excellent for primary key and highly selective indexes. So you can see here index organizer table. So that is one table. An index organized table differs from a heap organized because the data is itself an index. So index organized table means this is what the index organized table, it will maintain the data in this particular tables. Okay, so where the data has been stored. So we have the reverse key indexes. That means in the type of indexes, the bytes of the index keys are reversed. For an example, 103 is stored as the 301. So if it is reversing it, then it is finding the value also, it's fine. Okay, so simply the key value will get reversed. That's it. So instead of 101, it will go for 301. Sorry, 103. stores as the reversal of swipes, insert index over many blocks. It's nothing but here we are storing the value, right? Row ID or something. So it will reverse it. That's it. The key values. So instead of going for the skewness, so one particular value, it doesn't have more values. That's why we are going for reverse key indexes, descending order index, BTree cluster index. So all the different kind of indexes on the BTree. So descending order means the key value will be descending order. That's it. So why we are going for reverse, right? 103, 104, 105. In that way, you might be having many data, but 301, 401, 501, if you have this way, it will not have the same data. Okay, same data, it will not be stored on the same key values. Okay, so that's why we are going for the reverse key indexes. We are not going to do all this. Automatically, database will take care. These are all indexes types. Reverse key index, create index name on the table, create index salary column. This way, reverse you have to choose. That's it. On index. Okay, so you have the tables, metadata tables, user indexes, user index columns, statistics, expressions, all this. So this is user index, right? So that's what I have taken all underscore indexes, all underscore index columns, all this. This is what the indexes should be created. Create unique, non-unique indexes, index name on table name, column names, table space name if you have. Yes, you can mention the table space name also. Employee number, we have created an index, but it is already indexed, right? It will not be created. One more indexes are there, that is bitmap index. So what is bitmap index, right? For an example, if you have this is a unique key. If you have more unique keys like email ID, all this, it will go and store the value. Bitmap index, for an example, you have the data like India, USA, UK, okay, some countries you have, Australia, something like that, you have the data, you assume that. There are 4 different countries, only 4 unique values. So if you have the data, millions of data, it will take 1, 2, 3, 4 like this, it will take more values. So it will take the values, it will make an entry. Okay, first record, it's like India. Second record, USA. Third record, it will make an entry in the like this. Okay. So whenever you have more values of more unique values, that is repeated values, you have to go for bitmap index. What is that? For an example, if you take this particular table, department ID, you have 90, 60, 100, all this record, right? If I want to create index on the department ID column, you will get less cardinality. If you have very less cardinality, you have to go for bitmap index. What is that? If you take this particular table, if you have some department IDs 10, 20, 30, 40, 50, you have 5 department IDs. You assume that 5 only I have mentioned. You can go for more number of department IDs. See, even if you have 1 lakh record, employees are from these 5 departments only, right? It's a repeated value. First employee, department ID 20. Second employee, department ID 40. Third employee, department ID 10. So anyhow, all the employees, even if you have thousands of employees or 1 lakh employees or 1 million employees, the same value will get repeated if you have only 5 department IDs. So how the index table, the bitmap index table will make an entry oracle. This way it will take row ID like 1, 2, 3, 4, 5 like this. It will go for this way first record, second record. Then it will go for the unique values. First record 20, it will make an entry here. First record 20th department. Second record 40th department. Third record 10th department. 40th record, sorry, fourth record 20th department. So fifth record 30. So in this way, it will make an entry like this, the table. If you are selecting any values, select star from the table name where department ID equal to 30. So this is the one query you are you are applying to the database. So where it will go directly? First, it will go to the index table. The Oracle will go to the index table here. You are selecting what is the query you are selecting? Department ID 30. It will go to this particular one, and wherever you have highlighted, it will take the row ID here, row ID of the record, row ID of the record. So it won't search any other record. See here, it won't search any other record, right? If you are maintaining the data in this way, if I'm going to give you one particular query, it is very easy to pick the data, right? Very quickly you can able to pick, right? So whatever the data we have, even if you have millions of data, it is very simply, you can go to the wherever it has been highlighted. So that particular data you can take. So this is what it will retrieve. It will take this particular data. It will go to the corresponding values or row ID. So I can say it's a row ID. Then it will give you the data. So this is called a bitmap index. Clear on this? How the data will be stored in the bitmap index. So when will you go for bitmap index? Whenever you have very less cardinality, you will go for bitmap index. So BTree Index, bitmap indexes. So bitmap index are most appropriate on low distinct cardinality data. Okay, opposite to BTree indexes. This type of index creates a binary map of all the index values and store that map in the index blocks. This means the index will require less space than BTree index. Yes. So this is what it will store. The retrieval is very easy. Okay. So that's what, if you have very less cardinality, then you have to go for index one. Even if you have null values, definitely it will have different null value on one particular column, right? So definitely it will have the index, right? See, first record, if you have null values, it will make an entry here, null, department ID null, right? Department ID null. But that particular record will have the row ID, right? So it will make an entry here. Okay, if the department ID is null, yes. So 13th record, department ID is null. So wherever, if I'm searching like select start from employees where department ID is null, it will go to this, it will take this record and it will go to the particular corresponding row ID, it will pull you the data. So even if you have null values, that's fine, right? So more null values on the columns, yes, it will store here. So it will take that particular record. So this is what the indexes will do. Bitmap index, right? So how will you create the bitmap index? Actually, we do not have privileges to create the bitmap index. You can see here, create bitmap index on employees. You can go for gender column. Select count of star from employee data where gender equal to male. It will pull you very quickly the data. So that's what you can go for the bitmap index. While creating the index, you have to add one keyword called bitmap. That's it. While just creating the table, right? Sorry, indexes, right? You are going to create an index with the bitmap. Department ID. For an example, department ID already indexed. If you have index one, so how to drop the index? Drop index name. Department ID is this is the index name, right? So this index name, if you're going to drop, it will get dropped. So create bitmap index. That's it. Okay. But we do not have not enabled that. We do not have privileges in this particular system. We do not have bitmap index creation privileges. So that's why we couldn't able to create. But if you're creating the index, that index table we cannot see. It will make an entry in this way. This is the way it will take. But whenever you are going to query this table based on the department ID, it will quickly give you the data. Okay. So on employee ID, which index you will create? Unique values, which index you will create? Employee ID. And even for salary column, if you have more unique values, then you will go for BTree index. If you have repeated values, you have to go for bitmap index. Clear? These are two different index. And sometimes they will ask what is cardinality, all this. So I will tell you, this is the cardinality, all this. So function based index means if you are going to take the columns, like you are going to make the columns like uppercase, you are going to select it always. First name equal to uppercase, upper or first name. That's what you are going to select. In this way, you are going to select. So create an index like this. So this kind of index is called a function based index. If you are going to use a functions on the particular column very frequently, then you will create function based index. But this is very rarely used index. So you will not use only one function, right, on the column. You'll go for many functions. That's a different scenario. Reverse key index, create index name on student mark reverse. The reversed value will be stored in the sorted order. So that's what it will go for, reverse key index. Clustered index means, so how the cluster data will be stored, I will show you. This is the cluster table index. See here, this is employee table. You have employee number, employee name, department number. Okay. Departments table, you have another table. That is department number, department name, location ID. Right. So unclustered tables, related data stored. Okay. So this is what the data will be stored. If it is in clustered index, you are creating the clustered key on the department number. How this value will be stored? It will take department number on the both the tables like a 10, department number 10, sales, this particular location, and whoever is from 10th department, it will make here the entry. Okay, for an example here, 10th department, Smith, right? So like this, it will make all the 10th department employees here. This is the clustered table. So based on the department ID, we have clustered it. 20, another key values, 30, 40. So it will take the distinct value on the both the values, both the columns, and it will create the clustered index like this. Instead of storing the data in this way, clustered tables, related data stored together for more efficiently, it will be stored. This is called clustered table data. Clear? So Oracle, how this is what that will store. Okay, so this is what, see, for an example, if you want to create a clustered data, if you are storing this way for more tables, the combination of more than one tables, if you are creating this way, then it will create very quickly, it will retrieve the data if you are going for a department ID search. So this is the called index organized table. This is called index organized table. These two tables are called index organized table. So these are all the index types are available in Oracle.